going to walk through some of our amazing projects that students completed in the mathematical art class during week 6. And in week 6, they were exploring polar graphs. Polar graphs are not XY, they're related to a radius and an angle, and they're generated from trig functions. So the students started off with understanding trig functions and how they work, and then we transitioned into polar and started graphing those trig functions to create really interesting visual images. And so I'm going to share a little bit of their reflection with you, just so you can understand their inspirations and how things came about, along with the sample art pieces. And so this is the first one we have. The student was really excited. They found a really cool function in Desmos. A lot of what we do in mathematical art is investigative. So I'll give you some general functions to try, and then as students experiment and change those functions, they notice the pattern of how it shifts the graph. And so they're typically using a lot of different equations to generate these images, and to generate that equation, you really have to understand how changing a number, adding or subtracting number, shifts the whole graph so that you can make what you have envisioned in your mind. And so this student utilized some different values to create this cohesive design. And so it's been really interesting seeing how they connected this to their job. And so this is the image that they created. You'll notice that on the left-hand side, we use a graphing software. And so students are actually taking what's in this graphing software and they're generating the images with it. So what was also really cool is that you can change the colors. And the blue graph is particularly interesting because that's not a function that I had students explore, but they were able to kind of figure out what that does. And so it was really interesting seeing the different blue components in this graph. And what you'll notice is polar very much feels like a moving graph. And so you can almost see the movement that's happening within this image. This student did some additional research, as they do, because they plug things into Desmos and they see how it changes things and they want to understand it. And so the student started out by wanting to make a fish, but then found some more advanced equations, and that took them down a different road towards a butterfly. And so you'll see they've got some of the descriptions of the equations that they entered, and it's really cool because they have a great understanding of trigonometry and the way that trigonometric graphs change to polar because of the ways that I can see that they shifted this. So it's really an amazing product. The student then used lemniscates to create a flowery shape at the center of the butterfly, and they even added wings. And so this is the actual product using polar graphs. And so you'll see all the equations on the left, and you'll see the really interesting visual that they were able to make on the right. And this is definitely a masterpiece, both mathematically and artistically. So I was really impressed with the math behind this and seeing that they used e raised to a power, because that's, again, something that we didn't explicitly cover in the class. But during the process of these investigations with the software, students really find a lot of different things to look at. Um, Sometimes you have challenges as you're trying to figure out the graphs, because I let them explore and they investigate and they try different things. And so sometimes you do wind up with these crazy errors. And I really like that this student put that in their reflection, because there are some days that when you're working with mathematical software, you just kind of want to throw your computer out the window. And so they kind of documented some of the errors that they were finding, but even with those struggles, they really enjoyed the process of exploring these equations, and they were able to kind of arrive at some of the ideas of an infinity symbol, and with the spiral functions. And so we share a lot of these in our discussions, so they're able to pick up things from other students. And so these are the two images that they created. I thought the infinity symbol was particularly interesting because they were combining two circles that were perfectly symmetrical with their equations to generate that idea of the infinity symbol. I also, in my feedback, told the student that the bigger purple piece reminds me of a fidget spinner. So it's kind of, to me, looks like a fidget spinner with a spinner inside of it, kind of like what my kids would actually use. This next student really played with spiral curves. And so whenever we're investigating graphs, there's a variety of equations that you're working with and you're trying different things. And so this student experimented with the spiral graphs and kind of created this whirlpool shape. And it reminds me a little bit of like a spirograph, which was interesting because what these equations look like individually, they look nothing like a spirograph. But when you combine a lot of these equations together, you get this really interesting spirograph happening. And what the student has done is they changed the domain of the function. So that would be the 0 is less than theta is less than 10 pi. And because the graph of this equation repeats, that's what generated those spirals, was by allowing it to repeat between 0 and 10 pi. So that was really interesting for me because I didn't teach them how to limit domains in this unit. We did it before in the rectangular unit. And this student was able to take what they did in the XY plane and kind of replicate it here in the polar plane, because all it did was allow the function to continue repeating itself. And that's what gave us this really neat spirograph. And at the center, you can see a nice spiral. So it looks really nice. It looks like a flower. And it's a great piece of art as well as math. Now, in the next one I have here, a common theme is flowers in polar. Flowers are a lot of the product of the graph. So whenever you're seeing flowers, you're seeing a really neat way of changing the graphs. And then the student actually was able to create a stem using a piece of a spiral. So it's actually a fully spiral graph that then they cut to create the stem. And they use different variations of the lemniscate functions. And so it looks just like a flower. And what I found kind of interesting is this orange dotted spiral in the center. That corresponds to this equation over here. And so you're able to change the color of your graph. You're able to make it dotted. And so it really kind of gave the flower an interesting feel. And then limiting the domain of the spiral. So down here in green, we can see that stem. And limiting the domain of that spiral allowed us to have a stem on the flower, which was interesting because this was the only student that added a stem piece to it. And so it really kind of changed the feel of the flower for me by seeing that stem happening. So that was a really creative and great thing. This student had a rather long reflection, which is wonderful because I love hearing how my students think about things. And this student is that by cobbling together a lot of the basic equations in different ways, they could get really interesting results. So you don't have to come up with all these crazy designs and crazy equations. Sometimes just putting together really simple things can make some really interesting images. And so this student was kind of combining patterns and getting this architectural vibe from things, which was really cool because I've not seen a student have this type of take on polar before, and really looked at how the graphs intersect and how they behave with one another to make harmony. And so there's a lot of really cool parts of this reflection that I really appreciated understanding what their thought process was. And when I saw these graphs, they really reminded me of almost like sonar. So we talked a little bit about sound waves in week 6 and how the sound waves travel and how polar can describe that. And so to me, it almost looks like each of these graphs radiates out at the center. And it kind of just like has this feel of like a sound wave to me. So that was one of the really interesting pieces of this assignment, is that we've been manipulating sound waves, we've manipulated some light stuff, and so being able to take that manipulation and put it into a mathematical art piece was really interesting. This student had didn't have a reflection, but they were inspired by fireworks. So I actually had a bit of a conversation when I was doing the grading for this. And so if you look at the firework and you look at the product, they actually made the screen dark in the Desmos calculator. And then they selected colors and they integrated different variations of the sine function to kind of get this firework feel, where it's more dense at the center and then we have lighter graphs coming out from it. So that was definitely, I thought, amazing that they started with an image and they were able to kind of get to something in the polar graphing plane that really had that same look and feel. This student started playing around with the lemniscates and finding ways that they can manipulate them. They're difficult to shift horizontally and vertically because it's related to an angle, so you're not moving things like in the typical graphing plane. So I love that this student kind of practiced with that a little bit, and I thought that was really interesting. And so they were trying to shift the curves to seamlessly connect two spirals together. and create this silhouette that they had that looked like a butterfly. And so they were looking at something that was really vibrant. And this is kind of what they created. And so we can see the butterfly's wings. We can see this really vibrant background happening with a blend of colors. And so there's actually quite a few equations you can't see because of the scroll bar. But it's also a blend of, they're blending math and they're also blending color and kind of creating these designs with an artistic eye and a mathematical eye, which is really interesting. This student had a blast. This student every week tells me how much fun they had working with our graphing softwares and really just kind of playing around with equations to see what it does. And so I may butcher this word, but they were creating mandala-like patterns. And when the equation is copied with positive and negative versions of itself, it creates this four-leaf clover effect. So it's kind of like when we're doing that, we're reflecting and we get this really nice symmetric piece because we're reflecting part of the graph onto the other side. And so as you start to layer these pieces together, they discover they look like flower petals. And so this student actually shifted to how they do this to be in the actual polar graphing spiral. So you're able to see from the r equals 0.1 theta from 0 to 30 pi. Again, they're shifting that domain. And that's what made that radiating blue pattern out. The four-leaf clover piece would be this nice, pretty four loops here. And you'll see this student probably had at least 2 to 3 times what you can see on the graph, really, with their equations to be able to fully form this image. And so it's a really beautiful image. And again, the use of the colors and the way that they're combining these equations to make the visuals is really inspiring. This student had a really interesting design. This student is someone who really likes abstract work, and I've seen that kind of in their work throughout the semester. It's really cool having people in game design and transportation and illustration and fashion and seeing how each student is inspired by what they're doing each week. And so this student said they were inspired by artists like Frank Stella, who they saw in week 4. So as a part of us doing this mathematical art piece, I will share artists that have principles that are similar to this, and they're able to really explore that. And they also really like the Japanese artists. And so this was an inspired by piece, and they really nailed the inspiration when you look at the week 4 material and you're looking at these two artists. If they were drawing things in the polar plane, this would definitely be a piece that I think they would create. And so the other thing here is the students are using the slide rule feature of this software. And so what that slide rule feature is doing is you can kind of pull the slider back and forth and see how it alters your graph. And so it's a little bit of an interesting way to like immediately get changes instead of having to type the equation in over and over again. So that's kind of a really interesting piece. The student wanted to make a logo for themselves, and they were really channeling the infinity symbol like you can see in the middle, and the sands of time, which to me, I can kind of see an hourglass in here. And so I really thought this was interesting because this student really worked with the thickening lines. So again, that's all done in the technology of the graphing calculator. And you can shift and change the thickness of these lines. You can really play around with what you're graphing to really impact the visual a lot. And so the student did a lot of that on the backside of the calculator to make the really thick lines that look really nice. This is another one. I don't have a reflection to share from this student for this, but they had the similar idea of getting this flower where we've got multiple layers to the petals and then working the spiral in from the back. And if you're wondering why they're working the spiral in, that was because that's the other shape we explored this week. And so students were challenged to really blend together the two ideas using different types of equations. And so this student really did an excellent job. They also worked with the domains, which was not something that I explicitly stated, but it did turn out really, really cool. And this student really worked with some of the basic equations, and it is a great example that just because an equation is basic doesn't mean that it's simple mathematically, and it also can create a really complex visual. And so the student really played with the patterns, and that's kind of an interesting part of Polar, is it does create these really nice curved patterns. And so this student was looking at the relationship between living things and brought spirals in, thinking about the origin kind of as as a point, and then like the spirals were the arms of the creatures. So I really love getting these reflections because I always wonder, like, what makes you see this image? And so this to me, I can definitely see what the student's saying in the reflection. If I hadn't have seen the reflection, I would have thought this was like the old screensaver that we used to have on my computer when I was in middle school. So that's kind of what it immediately reminded me of, but that's part of why students in mathematical art complete reflections. Because as they complete these reflections, I really get to see the unique perspective that they're viewing things through, and I get to better understand their mathematical, their artistic drive here. And so the equations aren't showing here, but we have quite a few equations in play because you'll see that we've got these really tight spirals that are kind of moving out from the center here. And then we also have these semicircular petals that are coming from another graph. And we also have this orange spiral that's moving out, and it's moving out in a wider fashion than the other colors. And so really awesome. This was their week 6 assignment, and I couldn't be more proud of the students in my class. They're all phenomenal artists, and they're all just catching on to the math so well. This is definitely a higher level application of these types of graphs and functions that I see in a solely taught mathematical class. Like if we weren't even tying art in and we were just studying math, my students don't typically get to this level of understanding how the equation shifts the visuals. And that's really what this class is all about, is understanding visually when we do math. What are we creating? What are we analyzing? What are we interpreting? And then we relate it back to the real world. So while these images are beautiful and they're very artistic, they also relate back to sound waves, light waves, different satellite patterns. And that's part of what we've also been studying as we create these mathematical pieces, let's think about what they actually model in the real world. And so that's also been a great way for students to say, oh, I may have done this math before, or I may have done this investigation, but I had no idea that it was actually applying this particular principle in the real world. And so there's a really cool real world connection. And so as students are developing this really in-depth understanding of the math here, they're also realizing how is this practically used and what are the applications of it. And that's been a really cool thing to see. So great job on your week 6 projects, everyone. They were phenomenal.